Hey, so we're going to do an absolute value equation with linear and quadratic components. So first, what we're going to do here is we're going to turn this absolute value into the piecewise function that we use. So we're going to state that x minus 5 is the piecewise function x minus 5 if x is greater than or equal to 5, and it's minus x plus 5 if x is less than 5. So if you need to review that, just go watch the video on absolute values in the introduction. So now we have the two cases. We have this and this. So I'm going to try both cases. So I will say case 1. That is when x minus 5 equals x squared minus 8x plus 15. So I move these terms over, so minus x on both sides and add 5. So I get 0 equals x squared minus 9x plus 20. And that's equal to a factored form. And if you need to review factoring, just go watch one of those videos. Minus 5, x minus 4. So now I know that x equals 4 and 5. Okay? So these are possible solutions. We'll check them later. Now we'll do case 2. And that is when x is less than 5. So I have negative x plus 5 equals x squared minus 8x plus 15. Now we move everything to the other side again. Add an x to both sides and subtract 5. We have 0. That's x squared. And then we add x here, so that's minus 7x. And then we subtract, that's going to be positive 10. So that factored is x minus 5 and x minus 2. So my two possible roots are going to be 5 and 2. So we notice that we have a common root here anyway, but we're going to now check all our possible answers. So when we check, we take the possible root and we substitute it back in to see if they do equate. So we're going to do this here. I'm going to write that back out. We have x minus 5 equals x squared minus 8x plus 15. And my three possible roots were 2, 4, and 5. So now I put those in. I have the absolute value of 2 minus 5 equals 2 squared minus 8 times 2 plus 15. This is just the absolute value of negative 3, and that's 4, and that's 16 plus 15, so that's going to be minus 1. So that's 3 equals 3. That one works. Okay, so we know x equals 2 works. Now we'll check the other ones. We have x equals 4, so we have 4 minus 5 equals 4 squared minus 8 times 4 plus 15. And this is the absolute value of negative 1. This is 16 minus 32 plus 15. And what that gives me is 16 plus 15 is positive 31 minus 31. That tells me that this absolute value of negative 1 equals negative 1, and that's not true. And then we check our last one, which is the absolute value of 5 minus 5 equals 5 squared minus 8 times 5 plus 15. This is just the absolute value of 0. That's 25 minus 40 plus 15. And 0 equals 0. Yeah, okay, so we have two roots. So 4 is an extraneous root. That's right, x equals 4 is the extraneous root. So we know there are x equals 2 and 5 are real roots. And if we just want to graph that real quick, so this is y and x. If we graph x minus 5, we have here, and then we have this. So this is x minus 5, and this is negative x plus 5. It intersects at 5. Now we have a parabola here. So x squared minus 8x plus 15 has roots at 0 and 3. So x squared minus 8x plus 15 is just factored as x minus 3x minus 5. Sorry, I may have said those numbers wrong. Yes, that's correct though. So it has a root right here, and it also has a root at 3. So let's say about here. We know the parabola is positive, so it goes like this. And it goes up. And where was our other possible root? Our other root was at 2. So at 2, somewhere in here. And this would be our 2 points of intersection. And that's how we solve that. So, yeah, that's it.